Hey everybody, it's Mr. Fabeck here, and we're going to talk about homeostasis. So in this Fabiology video, we're going to talk about how you are the Terminator. Yes, you are a machine, half human, half machine. And we're going to talk about all these different body systems and really what they're doing. So this concept of homeostasis plays a big role throughout all of biology. So let's kind of get into it, and let's see how you are like the Terminator. That was okay, I guess. So here we go. This is a standard we're working on. Describe how the functions of individual organ systems are integrated to maintain homeostasis in an organism or terminator, however you want to interpret that. So in other words, and how we're going to show mastery is we're going to explain how two or more body systems are working together to maintain this, or this concept of homeostasis. So what is it? Okay, so homeostasis, this is a key term. You might want to write this down. It's maintaining a steady, constant environment for the body. So ultimately, we're kind of in this flux all the time. We're on this giant balancing act going back and forth, and we're trying to keep our body normal and functional. So what does this really entail? We have temperature. So body temperature, taking in nutrients, getting rid of waste and toxins, blood pressure, maintaining that we're able to bring that blood flow, bring those oxygen molecules to our muscles, and get rid of all this carbon dioxide throughout our body. Okay, so homeostasis is an important factor. So since we need it, let's talk about maybe what goes wrong if you don't have it. Okay, so the body wants to be in that first picture. It wants to be just like this, in this nice, perfect balance. It's not maybe too hot, not maybe too cold, but it's just perfect, right? But as we expose ourselves to the environment, then things get out of whack. The moment you eat something, you're going to have to start digesting those nutrients, and there's some stuff in there that may not be that great for you that you need to get rid of. Taking in a breath, and then having that go to your muscles or any other organ, and then now producing carbon dioxide in your body in a reaction, you got to get rid of that, right? So our body's constantly going back and forth. And if we don't maintain homeostasis, the cells cannot function. Ultimately, the cells can die, or it just throws off multiple systems and multiple problems. This is the idea of like cancer. When you get cancer, some of the signs are that your body systems are not working properly. Maybe you're, if it's a prostate thing or something in the urinary tract, you may have to pee more frequently, or you're getting blood in your urine, okay? Or maybe if you're having a brain tumor, you're starting to get headaches more, okay? So there's all these different signs, and it's ultimately showing us that our cells aren't functioning normally because of some problem, okay? So here we go. You could interpret this as your body's like a refrigerator, or a terminator, whatever choice you want, but essentially you're a machine, okay? You are a machine, you are a robot, and like a refrigerator, once you open it up and you're looking through there and you're trying to find your favorite snack, your snack pack, the butter or something, I don't know, whatever you're looking for, right? Once you open that fridge door, what's going to happen? You're going to let out a ton of cold air, and that cold air was precious to the refrigerator to keeping your delicious treats nice and cool. So what is the refrigerator going to do? We start to hear the machine turn on, right? We hear this rumble, and we start to maybe even see a little bit of some freon going into your cold air space there, right? We're starting to see the refrigerator trying to now maintain that temperature that you set it at. Once you close the refrigerator, then it can start to, really trap in that cold air, and then hopefully we'll get to that perfect temperature. And when we do, we don't want to keep putting cold air in the refrigerator, right? Once we're at a cold temperature in there, we want to keep it the same. So we'll just, wait, and if it warms up a bit, we'll start to, again, do this balancing act. We'll turn it on, turn it off, turn it on, turn it off, okay, so that we can ultimately balance everything in the fridge. Well, your body does this too, right? Think of just exercise, okay, or just going outside. Okay, we're in Minnesota. This is frigid cold weather out here. We have rapid temperature fluctuations from being indoors to being outside, right? So again, it's that balancing act. The moment you step outside in this cold air, right, you have temperatures in your integumentary system, your skin, that are going to say, that's cold, right? We need to tell somebody that we have a cold environment so that we can do something. So your brain then sends those signals, and then we start to get this thermoregulation, this heat regulation, and we start to tell muscles to start shivering. Those small contractions are enough to produce a small amount of body heat so that we can try and maintain these proper temperatures, right? The same thing with when you're exercising, right? You're starting to get too warm, or if it's too warm outside, what is your body going to do? It's going to send messages to your brain, again, that we're getting too hot. So what do we have to do? We have to tell these sweat glands in our skin to start releasing some water, because when water evaporates off our skin, it's going to cool our body down. So we have this constant movement, right? We're circulating up here, we're circulating down there. We have this balancing act of trying to keep this temperature nice and steady, a nice, steady environment. So what we call these diagrams, we call these negative feedback loops. So a negative feedback loop is to maintain homeostasis. Now it sounds weird that it's negative, but it's really going against whatever the feedback is. If the feedback is that it's cold, right? If you're telling somebody some feedback like your brain that it's cold outside, you want to go against the cold and warm up. So the same idea goes with blood pressure. If your blood pressure is increasing, then we have to do something like lowering our heart rate to decrease that. Okay, we're doing the opposite of what's trying to happen. That's what a feedback loop is. Okay, a positive feedback loop sounds great. Things that are positive sound amazing. However, this is going with the change. So if it's going with the change, it's leading us away from homeostasis. That is bad, right? That can cause those cells to not function. That can cause them to die. So an example, using the one before, of blood pressure, if our blood pressure is increasing, if it keeps going, if we don't regulate it and we have a positive feedback loop happening where we're going to keep going with the change, you could have a heart attack. You could die, right? There's too much pressure. Your heart's working too hard. It's not going to work, okay? There is one positive feedback loop that I can think of that is good, and that is childbirth. So ladies, listen up. Men, you too. This is where we want the positive, because although there's extreme pain, right? We're trying to shove this child out of our body. Although there's extreme pain, we are going to continue with the pain. Our body's not going to say stop stretching and contracting these muscles around the uterus, because we need to get that baby out. So we keep going with the pain until the baby's finally out. So again, this is another feedback loop. It's the same idea. We're seeing how we're trying to regulate these negative feedback loops, okay, to maintain a proper environment. So how else do we do this? I mean, there's a whole variety of examples. You got Shaquille O'Neal dunking there over Dennis Rodman. You got this basketball, you're heating up, your heart rate goes up, you're sweating, right? Your muscles are contracting. You got to get rid of some of those toxins like CO2 and lactic acid building up in your body as you're playing, right? Your body's trying to cool you down, okay? You have urine, just the basic idea of regulating acids and bases in your body, right? Your urine is a way to get rid of waste. So using the urinary system to flush out things from our food or from our diet. We have this little girl here who looks very, very sick. Yeah, when you get a fever, it's your body heating up to help your lymphatic system, right? Our lymphatic system is trying to catch all these little blobs of viruses and bacteria to get rid of them in the body as well, and break down them, send them to different glands and nodes to get rid of them. Calcium is an important mineral in your body. We get calcium from our diet, like drinking milk or anything along the lines of that. You can even take vitamins if you're lactose intolerant. But our calcium is stored in our bones, so if we don't have enough calcium in our body, we can release hormones, and there's a gland called the thyroid and the parathyroid glands. Those can trigger different hormones to release or stop the release of breaking down bones to get calcium in our body. Same thing if you're diabetic or if you know someone who has diabetes, regulating blood sugar is an important factor in your diet. And so the pancreas is a organ in the body that releases insulin to help us regulate the blood sugar. And if we have too low, we may get dizzy, we may fall asleep. If we have too high, we might have other issues going along the lines of that. So really, there's a variety of different examples. You could even talk about getting food poisoning. Our body said that was bad. Let's contract some abdominal muscles. Let's get rid of this and throw it up, right? Let's get rid of these toxins any way necessary. Okay, so I want you to think about yourself, your real life. Most of us have probably been in gym class or ran a mile, so we can kind of think about how all these systems are working together. Okay, so for you, I want you to summarize all of this information. I want you to have a journal. I want you to think of a real life scenario that applies to you. Okay, something that happens to you or an everyday occurrence, and I want you to use that real life example to explain how two or more body systems, such as the cardiovascular system, the heart and blood, or your muscle system, or your integumentary system, your skin, right? How are they working together to maintain this homeostasis? When you can write a good, solid half a page explaining this, I think you mastered this idea of homeostasis and can explain how you are the Terminator. Okay? So thank you very much, and we'll see you in class. Have a good one, guys. Bye.